To solve this quadratic inequality, the first thing that we need to do is find the values of this polynomial that'll make it 0. So we will set it equal to 0, and we will factor that polynomial. And by factoring it, we can use the zero product property and find that m is equal to 5 over 2 and m is equal to negative 3. These are the two values that'll make this polynomial 0. By knowing this, we can divide the real number line into intervals from negative infinity to negative 3, from negative 3 to 5 halves, and from 5 halves to positive infinity. So our intervals over here on the board are shown using interval notation, and we will choose a test point within each interval and test those points within the original quadratic inequality. So I chose to test negative 4 in our original inequality, and I found out that that was a true statement when I plugged in negative 4. So negative 4 is a solution of that quadratic inequality, which means that every other point within that interval is also a solution of that quadratic inequality. Then I tested 0, which is in my second interval, and found out that 0 did not make a true statement. It was a false statement, which means that 0 is not a solution of that quadratic inequality, and neither is any other point within that same interval. Next, I tested 3, which is in my last interval, and found it to be true also. It was a solution of the quadratic inequality. So every other point within that interval is also a solution. So our solution was the first interval together with the last interval, and we can combine those two intervals using union. Our solution of the interval from negative infinity to negative 3 together with the interval from 5 halves to positive infinity would be represented on the real number line as shown here.